All right. So, hello everyone. Hello everyone. How are you all? I hope you all are doing wonderful, right? So, welcome back to this particular channel of Pradhan Academy. And today we are coming back again with one more session, right? So, we are back with another session, and today's topic is going to be on the basic maths, right? And today we will basically discuss about the logarithm, right? So, logarithmic functions are a very important and an important part of mathematics, right? Now, you will see mostly in any chapter of mathematics, you will definitely feel the need of use of logarithms, right? So, therefore, I am back again with this particular small session on logarithms, right? So, so I would request all of you to please, if you are new to this particular channel, please hit the subscribe button and don't forget to click on the bell icon as well, because we are coming like every day in the evening, around the evening time, and we are basically discussing each and every topics of maths, and we are getting ready for the JEE Mains second attempt, right? So with this, let's start with today's session. And today our topic is going to be on logarithms, right? So logarithmic functions are very important. So I took up a time to basically discuss only the logarithmic functions, right? Because I feel that there are certain questions that you need to understand, and you need to use logarithms in many of the important chapters. Okay, so whenever you're dealing with an exponential functions, log is a very important thing. Okay, not only logarithm will be used only in calculus. Apart from calculus, you will be also seeing use of logarithm in complex numbers, in binomial theorem, and in sequential series, quadratic equations, and many more, right? So therefore I felt the need that it is very important to discuss about the quadratic function, the logarithmic functions, right? Also we will discuss about the logarithmic functions in the chapter of functions, but this is since this is very important, that's why I taking up as a separate part, right? This is also very important for the physics students as well, right? So basic maths, under basic maths, logarithmic functions are very important. Okay. So let us see how we basically need to, what all things we need to learn in this particular chapter, and what all concepts are important for this particular chapter in order to get your JEE Mains previous year questions done, right? So we'll discuss in terms of the JEE Mains previous year question. Along with that, we will also discuss about some of the important concepts and how to solve the different questions. Okay. So students who are new to this particular channel, I would like to repeat it again that we are basically discussing JEE Mains previous year questions, and each of the sessions we are discussing a particular topic, and in the live sessions we are discussing a particular topic where we are basically discussing the previous year questions along with the concepts. Okay, so if you haven't watched those sessions, you can go to the channel and check out the live videos. In the live sessions you will definitely find out the contents that have been so far covered, right? So we have already finished up with the coordinate geometry, and we started with the algebra part. In algebra we have already covered quadratic equations and sequential series so far, right? So if you are new to this particular channel, I would say please look out those old videos so that it will help you to reinforce the preparation for better for your upcoming paper. All right, so let's get started on this particular session of logarithmic functions. So today our goal is to discuss about the logarithmic functions. So logarithmic functions are very important. Now I am basically not going to discuss everything about functions, but I will give you what are functions, and we'll discuss specifically on the log functions, right? So please give me a thumbs up so that we can proceed with the session. All right, I hope you are ready with a pen and a paper, and we are ready to go with the questions, right? So let's get started on this part. So we discuss about the concept of logarithm. We also discuss about the previous year questions. We also try to practice some numericals as well as MCQ based questions, and we also see some of the previous year questions for JEE Advanced, and we try to predict what are the statistical outcome of the paper and what all types of questions you can expect to be coming up in your upcoming paper. So with that particular note, let's get started. All right. So let us first of all have a quick recap. Let us first of all have a quick recap on the properties or the definition of logarithm, right? So log or a logarithm is basically defined as, is basically of a given number is to a given base is the index of the power to which the base must be raised in order to get equal to the number, right? It is a very important definition. To understand this, let me tell, I will repeat this again. So logarithm of a number is basically of a number to a given base. So log of a number to a given base is the index to the of the power. So it is the index of the power that the base must be raised in order to get to the given number. So let me explain you in very detail. That is, if I have, so if I have a number like, so basically I am basically talking about that if I have a number like this, that a to the power x is basically given as n. So n is a number, right? Now if I take log of this particular number n, if I take log of this particular number n to the base a, then I'm going to get the log as x. So it is the index or the in power of the base that I should raise it to in order to get to the number n. That is what is defined as a logarithm, right? Now log of a particular number is only defined for positive base. So this there are some of the important things that you need to understand once you are going to discuss about the log, right? So if I have a function f of x is equals to log x base a. So some of the important thing that you need to understand that this particular function is defined only when it follows certain criteria, right? So that particular criteria is called as domain. So those inputs of x that I can put it into the function is basically defined as domain, right? So the domain of this logarithm function is given as that our given x should be greater than 0. Our given x should be greater than 0. And there is one more inequality that exists in the condition on A, that is basically our base should be greater than 0, our base should be greater than 0, and our base should not be equal to 1. Our base should be greater than 0 and our base should not be equal to 1. So if our function of log is satisfying this all criterias, then I am basically can say that a log of a function or particular number is defined. So this function f of x, so this particular function f of x equals to log x is called a logarithm function, and its domain is x greater than 0, that is 0 to infinity, and the range is all real number, and a is called the base of the logarithm function. When the base of the logarithm function is e or e, it is called the natural logarithm of Neperian logarithm function, right? And when the base is 10, it is called a common logarithm function. So if I be using some of the common terminologies, that when I say natural logarithm function, it is basically means the base of the logarithm is basically e, and if I have the base as 10, it is called a common logarithmic function. Then the logarithm of a function is a unique number, that is no number can have two different log to a given base. That is, if I have log of a base e is equals to log of 10 base e, then multiplied with log of a base 10, or log a base 10 is basically given as log a by log 10 with the given base e. So that is what you need to understand, is that a logarithm of a number is unique, that is no number can have two different log values for a given base. And if I have log of a base e is equals to, this can also be written as log of 10 base e multiplied with log of a base 10, that is called the base changing formula. Now I will discuss this part in the properties itself. All right, the next thing that you need to also talk about is that the integral part the integral part of a logarithmic is called the characteristic. So whatever, so for example, if you are having log of some particular number with respect to the base 10, if you are so you will be consisting of a, so any number can be done as integer part for fractional part, right? So the integer part of the log number is called the characteristics, and the fractional part of the log number is called mantissa, right? Now it is defined in respect to the use of logs, right? So I will tell you why we basically use logarithm functions and what is the use of logarithm function. So whenever we're going to use logarithm function, then only we're going to use a talk about this particular thing, right? So integral part of a logarithm function is called characteristics, and the fractional part of a logarithm function is called as mantissa. So the mantissa part of a log number is always kept positive. So the fraction part that you are keeping over here, that should be a fractional part function. That means this particular part should be basically between 0 and 1, right? So it should be defined like this. Okay, and the characteristics of the logarithm function bn, the number of digits. So if I need to find out the number of digits that is present in a number capital N, then I will take simply the log of n with respect to base 10, and what if I get the log n value as small n, so the number of digits in the capital N number is basically small n plus 1. Now this is very interesting and an important property that you need to remember. So if the characteristics is n, then the number of digit is basically n plus 1. This is a very important property. You need to keep this remembered, right? Next, also one more important property is that if the characteristics of a log of n base 10 is minus of n, if it is coming at as minus of n, then there exists n minus 1 number of zeros after the decimal part of the number n. So if the characteristic is turning out to be minus of small n, then there exists n minus 1 number of zeros. Then there exists n minus 1 number of zeros after decimal part of the number n. I hope this part is clear to all of you, right? So with this part, we are basically done with the small recap. Now, it is also important to understand some of the basic important properties that holds for the log function. So if I say that if I have m and n are the two arbitrary positive numbers such that a is greater than 0 and a should not be equal to 1, and b is greater than 0 and b should not be greater than 1 equal to 1, then log a base a is equals to 1. Okay, and log of 1 to any base is basically equal to 0. Similarly, log b base a into log a base b is equal to 1. Also, log a base a is equal to log b base b is equal to log b, and this particular relation will gives you an important relation, that is base changing formula, that is log b by base a is basically 1 upon log a base b. All right, so these are some of the important property that you need to look into, right? Next property is saying that log of a base e can be written as log of a base b into log of b base e. That is, I can write log of a base e is basically can be also written as by taking, or this is log of base c. Okay, this can be written as log of a base c can be written as log of a by log of c with the common base, right? Now this is called the product rule, that is if you have log of m into n, then it is basically given as log of m plus log of n with the common base, and similarly log of m by n with the common base is basically given as log of m minus log of n with the common base. This is called the power formula. It is called log of m to the power n is equals to n into log of m with the same base, right? Then we have very interesting and important formula that is called the base changing formula. All right, so this is a base changing formula, so that is let me write it over here. So if I have if I have a to the power b into log of c, then this can also be written as c to the power b into log of a. Now this is a very interesting and an important formula that you must remember. So if you call this a property, it's a very important property that you are going to use in many chapters. Okay. So similarly, the properties are written over here. I would request all of you to please have a look. All right. So these are all the properties that you can see over here. So I hope you understand some of the properties, and these are all clear to all of you, right? So this you all have basically gone through in the basics part of the chapters, or even if you have studied the entire syllabus, if you have completed the entire syllabus, then I hope you know all these parts, right? So please let me know if you have any questions. Otherwise, we can proceed with the questions. Please let me know if you have any query. All right. So if you have any query, please let me know. I will be looking through your live chat. All right. So I hope this part is clear to all of you. If this part is clear, let us move for the next part. And the next part we are going to discuss about, and the next part we are also going to discuss about some of the logarithm inequalities. Now, before I discuss about the logarithmic inequalities, let me tell you about the graph of the logarithm functions. Okay. So let me discuss about the graph of the log function. Okay, of the function f of x equals to log x with the base a, right? And our base should be greater than 0 and it should not be equal to 1, right? So therefore, now depending upon the value of this base, I will have multiple definition, and you will see that depending on the value of a, you will have the graph different, right? So let us draw for the first case. Let us take two cases, that is when our a is basically lying between 0 and 1, whenever the base is basically lying between 0 and 1. So when the base is lying between 0 and 1, it is a decreasing function. It is a decreasing function, which is very obvious from the exponential graph of the function, right? So it is a decreasing function, and the graph of the function will look like this. Okay, please let me correct my diagram once again. So the graph of the function will look like this. It's a very smooth curve like this. Okay. So going to minus infinity, and this particular part where it is intersecting is basically 1, right? So x equals to 1, the log will be equals to 0, right? So it is coming from positive infinity to minus infinity, right? But since it is not since the value of x cannot be, so our domain is x greater than 0, so value of x cannot be equal to 0. So therefore you can see it is asymptotic at this line x equals to 0, right? So therefore, you will have the curve of the function looking like this, right? Now, similarly, if you have the case when your base is greater than 1, then if your base is greater than 1, then the case is basically like this. So it is an increasing function and it will be concave downward, right? It is a concave downward, and you will have the part like this, okay? So your base is greater than 1, then it is an increasing function, right? And concave downward. Increasing function and concave down. Now, how I am getting concave down or concave up? It is basically determined by the second derivative of that particular function with respect to x. So, if the second derivative, so for this particular case, I will have the second derivative as negative, right? As negative for all cases. So, therefore, I see it is a concave down. And similarly, for this case, our second derivative is always, so you can see it is concave up, right? It's kind of concave up, okay? But with a decreasing function. So, that is what we have in over here, right? So I hope this part is clear. Now, if this is clear, then let us try to discuss about the properties, right? So let us start from this property because this property are very obvious, okay? So if I talk about that, I have log of a with a base m is less than b, then I will have two conditions. That is either our number a is less than m to the power b when m is greater than 1, right? Then the sign of inequality will remain as it is. But if the sign of inequality will change only when it is a decreasing function. That is when m is lying between 0 and 1, then only the sign of inequality will change because it is for the case of a decreasing function, right? And similarly, for the case of greater than, that is also wholly true, right? So I hope this part of the inequality is also clear, right? So these are some of the inequalities that you are going to see in the questions, okay? So with this, we are done revising the important part of the logarithm functions, right? So once you are done with this part, now let us now try to understand and go through the questions part, okay? Please let me know if this is clear or not. I hope you are able to follow me. So I hope this discussion is clear ever to everyone. If something is not clear, you can definitely put that as a live chat. Okay. So let me proceed with this problem then. All right, waiting for your replies. Okay. So please let me know if you're able to get it or not. All right. So I hope this part is clear to all of you, right? So these are the important part that we are going to use in the questions also. Okay. So please make sure that you understand this so that when you start with the questions, it will be very easy and clear to all of you, right? So let's start. So let us start with the questions. So here we have our first important question from the JEE Mains previous year problems, right? So if we look at the problem, it is basically given in terms of an exponential function with a logarithmic part, right? Now we are going to use the important logarithm properties in order to simplify this problem and in order to get a simplified equation in x, right? So let us start to solve this problem, right? Now some of the equations that you are going to see is basically will basically involve understanding about the domain as well as the range, right? So if you don't understand about the domain and the range, sometimes the question might be decisive to you, right? So let us try to see what this question will be talking about, right? So we have the given equation as, so our given equation, right? Our given equation is given as e to the power 5 times of e to the power 5 times of log x base e and log whole square of it plus of 3 is basically given as equal to x to the power 8, right? And it is such that our x is greater than 0. Otherwise, that domain is not satisfied, right? So in order to satisfy the domain, this must exist or this must hold true, right? Now, now let us try to simplify this particular equation. So what I can do it is that, so I can obviously I can simply apply some of the important properties, that is x to the power a, x to the power a plus b is basically given as x to the power a multiplied with x to the power b, right? So let us try to use the properties of the exponential functions, right? So from here I can write this particular expression as e to the power 5 times of log x base e and whole square of it, right? Multiplied with e to the power 3 is basically given as x to the power 8, right? Now Now let us try to understand that I need to find the product of all the solutions of the given equations. Now, rather going for solving it like this way, let us first of all try to take log on both the sides. So if I try to take log on both the sides to the base e, so what I'm doing, I'm taking log on both side with respect to with respect to e, right? With respect to base e. So if I take log on both the side with respect to base e, I'll have, now I will tell one more thing, that is log of any number x with base e or natural logarithm can also be written as ln of x, okay, or natural logarithm, okay, or ln of x, right? Like that we also write it sometime. So this can be given as log base e, and the quantity is e to the power 5 into 5 into x log x and whole square of it plus of 3 is basically given as log x to the power 8 base e, right? Now if I just try to simplify this part, so this part will basically become, now since I have this part I can just simply use the property of the power. So this part will come out and log e base e basically equal to 1. So therefore the left hand side I will have it as 5 into log x whole square of it plus 3 is basically given as 8 times log x, 8 times of log x, right? Now I will see that our equation is basically the form 5 times of 5 times of log x base e whole square minus 8 times of log x base e plus of 3 is equal to 0. So we see that it is basically becoming a quadratic equation in terms of log x, right? It is basically becoming a quadratic equation in terms of log x, right? Now if we try to understand from here, what we can further simplify it as, so let us assume log x base e is basically t, right? And x is greater than 0. So therefore, if we are putting back, this is basically according in t. So 5t squared minus 8t plus of 3 is equal to 0, right? Now we can further simplify and we can try to factorize this part. So if we try to factorize this part, it is going to basically be like 5t minus 3 multiplied with t minus 1 is equal to 0, right? That is how we have the factorize, right? So therefore from this we will have two roots, that is t is equal to 1 or t is equal to 5 upon 3 upon 5, right? So now we have to equate log x to this t in order to get to the values of the x, right? So that is equal to 1. So when log x is equal to 1, when x is equal to e, right? So log x equal to 1 when x equal to e, and similarly log x base e is given as 3 upon 5. So our x should be equal to e to the power 3 upon 5. So x should be equal to e upon 3 to the power 5, right? Now we have two solutions. Okay, one of the solution is x equal to e, and another solution is e to the power 3 by 5, right? So therefore the product of the solution, the product of the roots, okay, the product of the roots is basically equal to e to the power 8 by 5. So the product of the roots, that is e into e to the power 3 by 5, is basically becoming e to the power 8 by 5. I hope this is clear to all of you. So with this, we will have option number D as my correct answer to this particular problem. I hope this part is clear to all of you. Please let me know in the comments. Please let me know in the live chat if this is clear or not. I will repeat it again. If something is not clear, you can tell me. I will repeat it again. All right. So I hope this part is clear to all of you, right? So let us proceed with the next part. I hope this part is clear to all of you. So let us proceed with the next part. Okay, if there is something an issue, you can definitely stop me in the middle of the question and you can ask me for the doubts, right? Okay, and if you're someone who is watching this session after the live session is over, you can always put that question in the in the comment section. Okay, and please do join the Telegram channel in order to ask your doubts or get the notes of this particular lectures. Okay, so in order to get the short notes and the lecture materials, whatever I'm using for making this content, you can always find those contents in the Telegram channel as well. Okay, so make sure you join the Telegram channel. The link is in the description. So please find the link in the description and join the Telegram channel. Okay. All right. So with this part, we are basically clear to go with the next problem, right? So let us try to understand our next problem, right? Now, next problem is given in terms of inequality. So it is asking about that we have to find out the number of integral solutions of x for which this particular inequality, that is given in terms of log of variable base and variable quantity, is greater than 0, greater than or equal to 0, then how many number of integral solution will exist for this particular inequality, right? So let us try to understand how we proceed with the problem, right? So first of all, let us write the given inequality. So given inequality over here. Now something that came to my mind just recently is that now whenever you are actually solving these problems for the actual exam, you are given some rough sheet, right? Make sure that you don't use a rough sheet as if you are doing a rough work. make sure to use the rough sheet as if you are doing the actual calculations in your notebook, right? So that you don't mix and match each and every question. So for example, you are solving one question of physics and then suddenly you came to maths and you're solving one question. So your physics question is like this and your maths question is overlapping of each other. Then the answer of the maths question is coming to the physics answer and the physics question answer is coming to the maths answer. That should not happen. I have seen many students doing the same in the examination and they lose up marks. They simply lose up marks just by marking the wrong answer even after getting the correct answer. Okay, so make sure that you don't do that mistake. Whenever you're doing it in the rough sheet, please try to draw a margin between two questions, okay, so that you understand that what particular question you are basically discussing about, right? So this is clear to all of you. I hope you will follow that. Okay, so the given inequality is given as log of x minus 7 by 2x minus 3 whole square of it to the base x plus 7 by 2 is given as greater than or equal to 0, right? So we have to discuss that what is the inequality in x in order to get to the number of real solutions of x as integral solutions. Okay, we have to find for the integral solution of x, right? So let us try to find out the integral solution. So x belong to integer, right? And first of all, let us try to find the domain or domain of the bound of the solution, right? So the very important thing to find the domain of this particular function. So let us call this particular function as f of x. Okay, so we need to find for the inequality that is f of x is greater than 0, right? So if we try to find a domain, so we will know that the number inside the log should be greater than 0, right? And similarly, the base should be greater than 0 and should not be equal to 1 and should not be equal to 1, right? So from this quantity, we will try to find out the inequality. So from this particular inequality, we'll see that our x should be greater than equal to minus of 7 by 2, right? And x should not be equal to 1 minus 7 by 2, which is basically equal to minus of 5 by 2, right? So x should not be equal to minus of 5 by 2. X should not be equal to minus of 5 by 2, which is very obvious because x are taking the integer. So we have to ultimately level about the integral solution of x. Okay, so this won't be also coming into solution as well, right? Now important to understand over here. So we'll try to use the Webicam method over here. So I hope you know the Webicam method. And if you haven't studied about the Webicam method, please stay tuned. I will definitely discuss about the Webicam method in the upcoming sessions when we discuss about the functions. Okay. And I will tell you the how to solve the Webicam method is that whenever you have an expression like function of x by function of g, so to find out all the critical point means for which value of x you are getting the function of x or function of g as equal to 0. And you plot them on the number line in an increasing order or ascending manner, right? So if you see over here, your x is equal to 7 will put the numerator as 0, and similarly x equal to 3 by 2 will put the denominator as equals to 0. So let us try to plot them on the number line in the increasing order, that is with 3 by 2 and then 7, right? And when we will see that what is the coefficient of the highest, what is the coefficient that is present over here. As you can see, it is 1, right, which is a positive coefficient, right? So you just have to see what is the coefficient of x that is coming up, that is 1, right? So from here I will start with plus. Then if I have, so 7 is coming because of this particular factor, which is basically h to the power of some odd. So the sign of inequality will change over here and will come as minus, right? And similarly 3 by 2 is coming because of this particular factor in the denominator, so it is also h to the power 1. So again we will have a sign change, so that will be plus. So from here I'll get the inequality that is x should be greater than 7, x should be greater than 7, and x should be less than, 3 by 2, right? So therefore your bound on x should be like this, right? And also you have found out that x should not be less than 7 by 2, so it should be greater than 7 by 2. So therefore you have a closed bound on x that is basically belonging between 7 by 2 comma 3 by 2 union 7 to infinity, right? This is what you will have as the domain of the solution x, right? Now you didn't solve for the entire solution. Now this is what the domain of the function will look like. So we have only found out for the domain, right? Now to solve for the inequality, we'll have to solve for the inequality. So if our, so this particular part, now we have to check for two values, right? That is when I put x between minus 7 by 2 to 3 by 2, what I will see that if I put 3 by 2 over here, it is going to be, so I have to check when the base is basically been between 0 and 1, right? So if the base is basically between 0 and 1, then the particular logarithm function is basically a decreasing function, right? So let us try to take two cases and let us try to solve it. So the first case is, let us take the case of the increasing function, right? When our base 7 by 2 is greater than 1, right? So if this is greater than 1 and as well as x minus 7 by 2x minus 3 x square is greater than 1, right? Square is greater than or equal to 1, right? So this is what we will get the inequality as. So when this base is greater than 1, that means it is an increasing function. Therefore, I'll have the quantity, that is x minus 7 by 2x minus 3 whole square should be greater than or equal to 1 from the inequality. And now if we try to solve this inequality, we'll have it over here as 2x minus 3 whole square minus x minus 7 whole square should be less than or equal to 0. Should be less than or equal to 0. Now once we try to simplify this further, I will have the factors as, 3x minus 10 multiplied with x plus 4 is less than or equal to 0. So from here, I'll have x basically belonging to minus 4 and 10 upon 3. Minus 4 to 10 upon 3, right? Now I have one more bound on x, that is, let us label it as one equation, right? And similarly, we'll also try to solve for the second case. We'll also try to solve for the second case when our x plus 7 by 2 is basically between 0 and 1. That is when the logarithm function is a decreasing function, right? So if we take the decreasing case, and one more thing is to understand over here, that is x plus 7 is greater than 1. That means your x is greater than minus of 5 by 2, right? So we just need to take the intersection of this case. Let us call this case A, and we need to take the intersection of equation 1 and case A, and ultimately from this part the solution of x you are getting is basically lying between minus 5 by 2 to 10 by 3, minus 5 by 2 to 10 by 3, right? So this is what is the solution for the first case. And similarly for the second case, we'll have, so for this we'll have this our solution as x minus 7 divided by 2x minus 3 whole square should be less than or equal to 1. Now if I try to simplify this expression, that is x minus 7 whole square minus 2x minus 3 whole square is less than 0. So from this part I'll have the solution of x lying between, so from this part I will have the solution of x to be lying between minus infinity to minus of 4 union 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 10 by 3 comma infinity, right? So from this part I will have the solution of x lying between minus infinity to minus of 4 comma 10 by 3 to infinity. I hope this part is clear, right? So therefore now if I try to take this particular solution and take the intersection of this particular case, we started with the solution of the case when the x basically lies between this interval, right? And we got the value of x lying between this, so we see that there is no common intersection of these two cases. Therefore the x basically belongs to phi over here. So x belongs to phi over here, right? There is no solution for the second case. So ultimately you will see that the solution for the cases is basically in between this minus 5 by 2 to 10 by 3, except the point when x is basically except the point that is x is not including the 3 by 2, because if 3 by 2 is there, then our solution will be not defined, right? Our denominator will be negative. I hope this part is clear to all of you. Please let me know if this is clear or not. Okay, so with this you will see the number of integral values of x you are having in between this inequality is basically minus 2, minus 1, 0, 1 and 2 and 3. So this many number of integer values you will be seeing over there, and therefore you will be having 6 number of integral solution for x that will exist. So therefore you will have option number D as the correct answer for this particular problem. I hope this is clear to all of you. I hope this part is clear to all of you. Please let me know if this is clear or not. Hello Satyam, how are you? I hope you are following Satyam. Please don't forget to like the video and subscribe to the channel. Okay Satyam. Okay, so let us proceed with the next problem then. So this is clear to all of you. So we'll have 6 number of integral solutions that will exist in x, right? All right, so this is clear to all of you. So let's proceed with the next problem. And next problem is going to be an interesting problem. So this problem is basically a problem of trigonometric equations involving logarithm, right? So let us try to understand how to solve this particular problem, right? So this problem is very interesting. Let us try to see this problem. So it is saying that if the solution if the solution of the equation, log of cot x by cos x base cos x plus 4 times the log of tan x base sin x is equals to 1. So let us try to see this particular equation over here. So we will have log of cot x base is cos x plus 4 times 4 times log of tan x base sin x is equals to 1, and given x is basically lying between 0 to pi by 2, 0 to pi by 2. This is basically given just to satisfy the domain of this log function, right? So therefore we can try to simplify this part as, we can always simplify this part as, so let us try to do it. So instead of tan x, let us try to represent this in terms of cot x. So what I will do, I will get it over here as log of cot x base cos x minus 4 times the log of cot x, because cot x is basically 1 upon tan x, right? So I just use some of the properties and I can write like this. Now what I will do, now I will try to express, this particular quantity in terms of the base sin x, right? So how will I do that? So I can simply do that, but before I express that, I will tell you. So what I'm going to do over here is that, so since we are having now, in order to solve this inequality, we need to have the common base, right? We need to approach the answer in a common base, otherwise we are not going to have the solution for it, right? So we can also write this similar expression over here, and we can write this as 1 minus, now what I'm basically doing, try to understand. So I can write this also expression as 1 minus sin x, 1 minus sin x by cos x. How did I do that? So I can always write this cot x as, cos x by sin x, and then if I use the division property, so log of m by n is equal to log m minus log n. So then log of cos base cos is going to be equal to 1 minus log sin x base cos x, right, minus 4 times log of, now this is also, I'm going to say use the same property over here. So it is going to become minus 4 minus 4 times log of sin x base sin x. So sorry, cos x base cos x, right, sin x, right? So you will have the base over here as sin x, and the this part is going to be equal to cos x, and that is equal to 1, right? So therefore we are obtaining a equation in this, right? So now interesting part over here is that if I considered or assume that our variable t is equals to log of sin x to the base cos x, then this part log of cos x to the base of sin x is equals to 1 upon t. So if I assume this sin x, log of sin x base cos x is equal to t, then this particular part is going to be equal to 1 upon t, right? And the advantage of doing is that, so therefore we will get a simple equation as t plus 4 upon t, So I'm taking this on the right hand side, will be equals to 4. I hope this is clear. Will be simply equal to 4, right? Please let me know if this is clear or not. I hope I'm doing correct. Okay, so from this part you will see that this particular solution will hold true, or this particular part will exist only when your value of t is equal to 2, or it exists only when your value of t is equal to 2. Now if your value of t is equals to 2, therefore your log of sin x base cos x, that where we have assumed as t, log of sin x base cos x is equal to t, and that is coming out as 2. So from this part I will have sin x is basically equals to cos x square x, right? So that is what we will have over here. Now I can always write this cos square x as 1 minus sin square x. So from here I will get a solution, I will get a quadratic equation in sin x, that is sin square x plus sin x minus of 1 is equals to 0, So from this part I will obtain the solution in sin x, and our solution of sin x by using the Siddharacharya formula is going to be minus 1 plus or minus square root of 5 divided by 2, Now since your x is basically between 0 to pi by 2, sign should be positive. So therefore the only solution of sin x should be equal to minus 1 plus root 5 by 2, right? So from this part I will have the value of x. So from this part I will have the value of x as sine inverse of square root of 5 minus 1 by 2, which is nothing, which is basically mentioned in the problem, as it is said that this particular solution of x is basically given as sine inverse of alpha plus square root beta by 2. So that is going to be equal to, so beta over here I will have it as 5 and alpha over here I will have it as minus of 1. Therefore my value of alpha plus beta is equal to 4. That is what is asked in the problem. So from here you can see that option number C is going to be the correct answer for this particular problem. So 4 is my correct answer for this particular problem. That is option C. Okay. So I hope this part is clear to all of you. Please let me know. So this part is clear to all of you. So I hope this solution is clear to all of you. If something is not clear, you can definitely tell me in the live chat. Okay. I am trying my best to clear all of your doubts. So if you have any doubt, you can definitely ask me in the questions as a question. Okay. And please make sure that you don't forget to join the Telegram channel. Okay. Because in the Telegram channel, I will be sending you some of the mock tests, the short notes. Along with that, I will be also sharing this contents or the lectures material that I have prepared so far. Okay. So I hope that you will do this needful, right? So let us proceed with the next problem. And the next problem we have with us is a simple problem from the numerical type problems, right? So we also need to check into the integer type problem as well, right? So let us try to understand the numerical type problems. Okay. So we have the numerical type problem. So this is a very interesting problem. So let us try to see what this question is talking about, right? So if I have the given inequality or given equation as 2a to the power log a base e is equals to bc whole to the power log b base e is equals and is therefore given equal. So from here, if I take log on both the side, or what I can do, if I take base changing formula also, and or let us try to proceed with the log of both the sides. So if I take log on both the side, natural log both the side, so I'm going to get it as answer as log a into log 2 plus log a, and that is basically equals to log b into log b plus log c, right? And all a b c are distinct positive real numbers, right? So they are all positive in order to the base to be satisfied. And similarly we have one more equation, that is b to the power log 2 is equals to a to the power log c, right? From this we can also write this as l ln 2 into log b is equals to ln c into ln a. So this is our second equation. So we have one equation and we have our second equation like this, right? Now let us assume that our natural log a is as x, right? If I assume natural log a as x and natural log b as some y, so if I assume natural log natural log a as x and natural log b as y, so what we and let us also try to put natural log 2 as some p and our natural log c as some z. Okay, so let us try to assume these particular quantities. Then if we assume these quantities, then if we try to put that into this equation, so putting into this equation 1 and 2, right? So putting into this equation 1 and 2, I will have p into y is equals to x into z, and I will have x into p plus z is equals to, sorry, p plus x. Okay, p plus x. I will have it is equals to y into y plus z, right? From here I will find the value of p as xz upon y, and we just put it back into this equation. So it is going to be x into xz upon y plus x is equals to y square plus yz, right? So from here we can further simplify it as x squared z plus x square y is equals to y square. Now there will be one more y square into y plus z. That is what we are having, right? Now therefore we try to simplify this out, factorize it out. So it is going to be x square minus of y square. So what I'm doing, I'm basically taking this part and this part of z. Okay, so x square minus y square z and z, and you will see that x square minus y square is also coming in common for y as well. So therefore we are having combined as, so it's all about calculations. Okay, so I'm having this like this, right? So it's all about calculation. So from here I'll get two solutions, that is either x is equal to plus or minus y, and also I'm having y is equal to minus of z, right? So I having closed form solutions, that is x is equal to plus minus y or y is equal to minus of z, right? Now I will have two cases. If x equals to y, then in this case x and y are the natural logarithm of a positive number a and b. This implies a is equal to b. Now this can be true. So if I take this case, that is x is, so from here if I take the case x equal to y, that means I will have A is equal to B, which is not true. So this particular case cannot be equal, right? And if I take the case when x is basically equal to minus of y, x is equal to minus of y, then I will have A is equal to minus of B, or B is equal to minus, they are reciprocal of each other, right? Now this is obvious from the case, right? And similarly for y is equal to minus of z, I will have this B is also equal to 1 upon C. I will have B is also equal to 1 upon C, right? So therefore, if A is equal to 1 upon B and B is equal to 1 upon C, so from this part, I will have this as C is equal to A. So this is also not possible because they are all distinct possible solutions, right? Distinct possible solution. Thus, in the case x equal to minus of y, the possible values are b is equal to 1 by a and c is equal to a. Right. Now, let me first of all understand that c is also given as distinct positive real numbers. Right. So, if c is equal to a, now we have to understand this very nicely over here, that if our c value, if our c value is equal to a, if our c is equal to a, and we have equation as b into c is basically equal to 1, so that means I can put it back into the equation as 2a to the power 2a, and also I will have 2a to the power log a is equal to 1. 2a to the power log a is equal to 1, and therefore from here I will have the value of a is equal to 1 upon 2. So I will have the value of a is equal to 1 upon 2, and so if I take these following values, I will have the solution for, I have the solution for 6a plus 5 times of b into c is basically equals to 6 times of 1 by 2 plus 5, 5, right? So from this part, I'm going to have the solution as equals to 8. So the integer value of this particular expression 6a plus 5 times of bc is going to be equal to 8. I hope this is correct and clear to all of you, right? So the answer to this particular problem is going to be equal to 8. Please let me know if this is clear or not. Please let me know if this is clear or not. Right. So with this, we are almost done with solving the important previous year questions for the chapter of log. Okay. Now I have one more problem. That is, I want to give this particular problem as a homework problems to all of you. Okay. I will discuss the solution. I will discuss the solution in the Telegram channel. Okay. So I will discuss the solution in the Telegram channel. So in order to get to the solution, you have to join the Telegram channel. Okay. Join the Telegram channel. Also, you can let me know the answer in the comment section, whatever you're getting. Okay. So please join the Telegram channel. Okay. And the link of the Telegram channel you will find in the description. Okay. Link in description of this particular video. Okay. This is very important to understand, because please make sure that you join the Telegram channel, because I will be sharing all my further upcoming updates on the Telegram channel itself. Okay. So please solve this problem as a homework problem and let me know the answer you're having in the comment section. And if you're able to solve it, I will definitely take up certain advantages for you, right? So there are certain benefits that are basically lying up ahead in the curriculum, right? So you will definitely see there are a lot of benefits that you will get by solving this, right? And this is really interesting. This will also help you to prepare for your JEE Mains upcoming attempt. Okay. So I hope this part is clear to all of you. And with this, I hope you got something from this particular lecture. So I tried my best to explain you what are the different types of questions that can be asked in the from the chapter of logarithmic functions. Okay. So these inequalities are clear to all of you. And whenever you discuss a question on inequalities, please make sure that you study the domain part clearly. Okay. So with this, let us end our session over here, and thank you. I wish you all the best.